So today we're going to talk about Twilio's answering machine detection solution and how it can be used to create a better outbound calling experience. I'm going to introduce myself. I'm Vineet Agarwal. I'm a senior product manager at Twilio.
Hey everyone, I'm Ankit Agarwal. I'm on the sales engineering team here at Twilio. Yes, we are related. Hopefully I do a good job, otherwise Vineet's going to tell my mom.
So I'm going to start off and talk a little bit about automated calling, some of the challenges that businesses face when trying to do automated calling workflows, how answering machine detection can play a role in improving that. And then I'm going to hand it off to Ankit, who's worked with some of these customers to talk about specific things that they've done to try to overcome some of the AMD challenges that do exist. And he's going to do a demo as well, and I'll wrap up with kind of what's next. And I think we'll have time probably for a few minutes of Q&A at the end. So let's get started. Okay, the automated calling problem. So I think a couple things that I want to point out, for businesses that do automated calling, they're trying to reach out to customers and provide some information, alerts, notifications, other types of use cases. There's two primary challenges that exist. One of them, I think we're all pretty aware of, is that answered calls are declining. These are just some numbers for a point of reference, estimates of 25 billion spam calls sent last year, and this number is increasing. These numbers are going up. And the result of that is that answered calls is decreasing. So 24% estimated of calls last year were actually answered when the number was unidentified. And again, that number is going down. And so the result of that, of course, is that customers are not answering their calls, and they're missing both the spam calls and fraud calls that they don't want to be receiving, but they are also missing the other calls that actually have value for them. And so that's something to be aware of and acknowledge whenever you're talking about outbound calling. It's something that that's the reality that we live in today. The other challenge is around really how do you provide the right experience, both for the agent, if there's an agent in the workflow, as well as for the customers, right? So an example, you don't want agents to be connected to machines because that's not really good use of their time. And from a customer side, here's just an example of if you don't do this well, what's the type of experience you can get for a customer?
First, skipped message. August 7th. Please press 1 to confirm this appointment or press 2 to change it.
So not a super useful voicemail. It's cut off. You hear there's something about an appointment. And it's asking you to press a digit because it's an IVR message. Doesn't really make sense. At that point in time, if you try to press a digit, probably won't do anything. The call is ended. So that's where, if you don't have any context on that call, you can leave a voicemail like that, which is a pretty poor customer experience. So when you consider these two problems, the first one, answered calls declining, not going to really be able to give much solutions in this talk today. It's a broader problem. There are some things in the industry that there's some progress in this front. Stir Shaken, you may have heard of. I'd recommend finding out a little bit more about that. But the one we really want to focus on today is around the agent customer experience, and really how can you optimize that experience. So for the calls that do get answered, how do you make that experience as good as it can be, and control what you can control ultimately. And this is something that is under your control. So with that, that leads into answering machine detection. And many of you are probably familiar with this, but just a quick overview of what answering machine detection, or AMD, is. It's a solution that will inform your application that's making the call, whether a human, machine, or fax actually answered the call, so that you can tailor your workflow accordingly. So since some of you probably do have context with AMD, I think a couple questions that probably come to mind that I've heard is, hasn't AMD been around for a really long time? Doesn't AMD suffer from performance challenges around accuracy and delays? And the answer to both of those is yes. But the reason we're talking about it is because we want to talk about Twilio AMD and kind of what we've done and how that solution's evolved. And specifically related to the challenges, we want to highlight those challenges and talk about how our customers specifically have tried to address those challenges. And I think those will be useful for you as you consider incorporating AMD or improving your AMD experience in your workflows. So what are the few things that AMD can do? I've highlighted a couple of these already. One is you can customize the human versus machine experience. If you know whether it's a human or a machine answering the call, you can connect agents with humans and not machines. And then you can actually leave voicemails properly. So if you know when the beep has occurred, you can actually leave the voicemail at that time and avoid the experience that we heard before. So if we look at all Twilio's AMD customers, I think there's three primary segments that we see. And the first one is alerts and notifications, super common use case. You're trying to provide some information to customers in a scalable way. Typically you use automation to do that. Appointment reminders is a great example. Outbound IVR, this is similar, that you're trying to provide some information, but you're also allowing the customer to provide some inputs back. It could be a survey, it could be an appointment modification. Again, the voicemail we heard was an attempt at that, where the customer can press certain digits to change the appointment. And a third one is an outbound sales use case. It doesn't necessarily have to be sales, but that's a common scenario where you're reaching out to a customer and you would potentially connect them with an agent to get more information. So insurance coverage, if you're trying to reach out to customers for insurance and they've expressed interest in that product. Another really interesting example, there's actually a talk later today on this, is a customer, a nonprofit who reaches out to customers to provide more access to food stamps and provide them that information. And so they actually have AMD in their workflow to optimize that workflow as well. So you can check that out later. So just really quickly, what does the workflow look like? The business app, if the calling app makes a call to the customer answers, hi, this is Vineet, there's some period of silence, and Twilio AMD is running. It's listening, okay, is this speech being said? What's the length of the speech? What's the period of silence? And then makes a determination. Notice there is a period of silence, right? Because that's how AMD works today. It says, is the greeting complete? And then it returns, hey, this sounds like a human, sends it back to the application plays the message. So, one thing to point out, it is a sequential process. There is that period of silence where the human is waiting while AMD is making its decision. And I want to point that out because one of the workflows we're going to talk about is how do you really address that workflow and that synchronous workflow that we have. Machine, this is another example. It's a longer greeting. Twilio AMD detects it's a voicemail, waits for the beep, and then responds back, hey, you can leave your voicemail at this time, and then the application can actually play the voicemail at that time. So playing it at the right time, avoiding the cutoff scenario we saw before. So just a couple minutes on Twilio's AMD evolution. We started off in 2013 with a V1, and we didn't have much investment in it for a while. We relaunched in April 2017 with the public beta, got some feedback on that, and ultimately launched with the latest version, and now we are generally available. It took a long time to get there. And I just wanted to highlight a few points of feedback that we got that were kind of inputs to the solution that we ended up with, which is what's generally available now. So a few things. One, we did learn that AMD was valuable, and I think that was really important to hear customers' use cases, how it helped them, and what are some of the challenges they faced. But it also, just reinforced our continued investment, and we have been investing more in the solution because we realize of the significance it has for customers and having a high-quality solution. Two, our previous AMD solutions just frankly didn't meet the bar. We got consistent feedback from customers that we would be very unreliable. In some cases, you would see detection delays of a couple seconds, and sometimes it would be 5 or 6 seconds. And so they didn't have the consistency of the performance, and so that was obviously very frustrating, and they had no controls. They had no ability to affect the performance in any way. And so both of those led to a lot of customer frustration. Related to that, it was generally AMD was not very well understood, and I think part of that was because of how Twilio talked to customers about it. It was too often referenced a little bit more of a black box, and it was unclear for customers what works, what doesn't work, what are the challenges, and so that was a valuable point of feedback for us to think about when we improve the solution, what are things we can do. So taking that feedback, the two major changes we made, which is for the solution we just released, one, we replaced our underlying engine. It addresses a lot of the performance and reliability concerns. It has much more consistency. You can kind of know what to expect. And obviously that's really important for customers. And so that was a big change that we made. And then the second one was we added transparency and configurability to our solution. So it's no longer a black box. We tell customers very clearly this is what it does, this is how it works, this is some of the challenges you can face and how you may potentially overcome them. And so the best way we thought about doing that was actually just to expose the parameters that already existed today in our internal engine and make them publicly available. So through the API or through Studio, as Ankit is going to show, you can actually change the default parameters. So we have the defaults based on a large set of calls that we've trained with, but ultimately there are some some corner cases or some use cases where customers want to adjust the performance. And we're going to go through an example of why you would want to potentially do that. And so that's now available for customers to use. So despite those improvements, AMD does still have challenges. And the two that I've referenced and that will still exist on some calls are inaccuracy of detection or delays of detection. And so specifically for these two issues, we've had customers tried to overcome them, and we want to highlight two of those examples. And so AMD tuning is the one I referenced that we've added these new parameters. We'll show an example of how you could use that. And the second one is this new idea of a background AMD, where AMD is not a synchronous process, but it can actually run in the background, which provides a much better experience and performance. And so with that, I'm going to hand it over to Ankit
Sweet.
To do a little demo.
All right, who's excited for a demo? I know he is. Awesome, so we're going to walk through two scenarios here. The first one's going to be more of a basic call just to see how AMD works at its default state on a regular call. And then we're going to jump into a short voicemail greeting, which is a pretty common use case we've seen from customers, and how the new tuning controls can help with that. So jumping into it. So we're going to be using Twilio Studio for this. For those of you who don't know what Studio is, think of this as our visual application builder, right? I, as a business user or a developer, can come in here and drag and drop widgets to build conversational workflows, whether that's IVRs, ITRs, even mass outbound calling campaigns. All of that's supported through Studio. And I've actually built a small little outbound calling flow within minutes. So here I've got an outbound dial widget. We're basically just going to call my cell with the answering machine detection on. Once the call is answered, we're going to analyze, is this a, whoops, too much. Is this result a human? If it's a human, we're going to go down this path. Otherwise, if it's a machine, we'll go down this path. So super simple. I'm going to initiate my flow via Postman and a REST API request. Hey, this is Ankit.
Hello, I've successfully detected a human answering.
Cool. Super simple. By default, if a human picks up, it returns the result of a human. Now let's try that again, but this time I'm going to let it go to my voicemail and see what happens there. So we're actually going to jump into our call logs in the programmable voice console. And the reason we're actually using this is because there's no good automated way today to view how your AMD performance is, right? A lot of our customers actually have to go in, listen to recordings, and do all this manually, as we are doing it right now. So call was answered and completed. Let's listen to that.
Please leave your message for... Hello,
Ankit,
I've successfully detected a human answering.
So two things wrong there, right? One, it detected a human answering, even though it was a machine. And two, it started playing the message right away before any beeper indication of when to play it. So what we're now going to do is actually jump into Studio and go back to the call widget and modify those tuning parameters. Vineet, you want to walk us through that?
Yeah, sure. So the reason we're highlighting this use case is this is probably the most common example we've seen where the standard AMD doesn't work. Standard AMD parameters don't work very well for this use case because of the fact that there's this very short initial greeting and then a long period of silence, and that has the characteristics of a human greeting. And so there are a couple parameters that could be potentially adjusted to better account for this. Now there are trade-offs that you're making when you make those changes, and we'll get to that in a second. But this first parameter here, speech threshold, this is really that length of initial greeting, and then the speech end threshold is what's that period of silence to wait for to know that the greeting is complete. And so you can actually potentially get this correct with adjusting either one. But for the purposes of this demo, let's adjust that second parameter, that period of silence, to be a longer period so that AMD is waiting a little bit longer to see, is the greeting continuing? And if it's continuing, it's interpreted as a voicemail, and it's going to detect it correctly. So we can increase this to a larger value and republish the flow.
Save that, publish. So with a single click, I've updated my flow. I can just do another call. Reject. And in Studio, you actually get a live execution log. So I can see that this flow is currently running, what node is it on, what widget is it on. So a lot of this data with Studio is in the UI as well as programmatic, which kind of helps. So I can see it made it to the voicemail stage. Call's completed. Let's refresh again. And we got a recording.
Please leave your message for
Ankit Agarwal.
I have hit the answering machine. Leaving a message now.
Great. So successfully detected an answering machine and left a message at the right and appropriate time. Now, we've solved for this case, but the downside of a workflow like this is, imagine a human picks up, that delay or that awkward silence gets a little bit longer. So one of our customers actually took it upon themselves to use the tuning controls as well as another solution to help address this experience. And that's what we call background AMD. So what is background AMD? So AMD today, the way it works is no action or no media can be played during detection. So you're kind of just stuck, you wait. The problem is that awkward hello, and then you wait 2 seconds and then you hear the recording. And the solution this customer came up with was, as soon as that end user picks up the phone, start playing them an audio message right away while AMD is running in the background. So what does that look like, right? Well, this is just one example of a way this customer did it. But basically, a lot of this revolves around Twilio conferencing. So essentially, you have 4 participants in your conference at any given time, right? The first one is the customer. You make an outbound call to your customer, put them in the conference, the customer picks up, says, hello, or hey, it's Ankit. That audio is getting piped directly to the AMD engine. While the AMD engine is processing that, simultaneously, you have another participant in the conference, which is your play TWIML or your audio message leg, and that audio message is piping audio directly to the customer. So something like, hey, this is Twilio Owl Bank contacting you based on your inquiry on our website, yada, 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 right? The customer's hearing this, and 2 things can happen now. The AMD engine will return human, at which point you can seamlessly add an agent to the conference. The agent now will hear that message, know when the audio message is complete, and can just start talking to the customer right away. No delay, nothing. Or if it's a machine, you can actually kill that initial audio message and know the beep's coming, because that's when you get the API request, and play a new voicemail that's more catered and directed to that customer. So just an example, but you really get 3 benefits here, right? A, you've taken care of that awkward silence that you have where you're not waiting for the hello. You've increased AMD accuracy, right? The longer the AMD engine has to process that audio and understand the silence, the stronger its accuracy is. And 3, altogether, you just have a better customer experience, right? In this specific use case, I, as the end customer, know why this business is calling, who I might even be speaking with from an agent perspective. So to summarize.
Cool. So just to go over quickly, so AMD is that first layer of intelligence that you can add to outbound calling. The Twilio AMD solution has been improved, is now generally available. There are tuning parameters available to adjust the performance. Now, of course, there are performance trade-offs you have to evaluate when using those. And consider background AMD as a potential workflow improvement. One thing, Ankit went over a specific how the customer implemented it and specific for their use case. We're going to try to make that easier for customers going forward if that's ultimately the experience that customers want, so that it's not something they have to build and it's kind of more out of the box. So these are kind of the main points we wanted to touch on. Can you go to the next slide? So going forward, we're investing in AMD going forward. GA is not the end. We want to continue to improve the solution. One of the things we talked about is background AMD. The feedback from customers is really important. Our roadmap is driven by customer feedback. So please let us know if the experience, for example, we talked about here is something that you want, if there's other improvements you would like to see, other challenges you're facing. The other thing we want to mention is that customers have long asked for more flexibility in our platform. And so one thing related to AMD is there's Twilio Media Streams public beta is launched now. And so that means that you can get real-time access to the media stream. So if you did want to implement your own solution or integrate with another provider, you now have that flexibility. So we want to continue to improve the offering that we have. We also want to give you the flexibility to do something else if you want to do that. And so that's now available as well. Cool. So check out AMD, see if it's relevant for your use case. If you haven't done so already, provide feedback to me and Ankit. We're going to be around after the talk. As you can email us directly as well. There's also, I mentioned, Stir Shaken, Twilio Media Streams. There's both discussions on those topics at Signal. I also referenced a customer that's using voice and messaging and AMD as part of their workflow to reach out around food stamps and making that more accessible. There's a talk, I think, at 4 o'clock later today that customer is going to be giving as well. So thank you all for listening. We have a few minutes, so opening up if there's any questions. Yeah, you can. There's also a mic there right behind you.
Yeah.
Yes.
So the background AMD has an extra cost?
Yeah, so the extra cost is going to be the conference, the Twilio conference piece.
Okay, so it's 2 calls?
Yes.
Okay.
Yeah.
Thank you.
Yeah, today it does because we don't support it out of the box, and so it has to be sort of implemented on top of what we have. In the future, when we offer it more as a solution, then it will be natively within the product, yeah.
On the Playlist, the company name they were announcing?
Yeah, so the way they're doing it, they're saying, this is the bank calling, here's why I'm calling, and maybe an agent introduction, whatever, but it's really up to you. You can kind of control that audio.
And is that audio not getting detected by the AMD?
Correct, yeah. So
How
the way
is that? Because the AMD is only on a single leg?
Yeah, so good question. Basically, the way you set up the conference, you can have individual participants talking to certain participants. So imagine 4 people in a conference, right? Where the customer and AMD are talking, and then the Play, Twiml, and the customer are talking. But the general overall audio is not shared by everyone. So you can control that.
So you can control which participants hear which legs.
Exactly.
So the call recipient can be hearing essentially 2 legs, but AMD is silent, and then...
Right. And whereas the agent hears everything, right? Or the agent hears the play message and the customer.
And the agent, okay.
Is brought in at the end once you detect, right?
Okay.
Does that make sense?
Yeah, it does.
It's basically using conference whisper, if you want to look up that attribute.
okay.
So, yeah, so like a whisper example would be if a supervisor is talking directly to an agent, they're saying something, but the customer can't hear that. So using that same concept, AMD is now listening to the customer leg, but not listening to whatever else is in the conference. So it doesn't hear that play message. Otherwise, obviously, that would affect the AMD detection. It's really just listening to what the customer is saying and can make that detection accurately.
It is, I think when we've looked at this before, you can determine what AMD does, either terminate the call or there's a wait for beep command, is that right?
Yeah, so there's a couple different modes of AMD, and I'm not sure if this answers your question, but one mode is I want to know as soon as there's a voicemail. As soon as you know it's a voicemail, let me know, so I can maybe drop the call. Another mode is if you detect a voicemail, wait for the beep and only respond back to my app when the beep has been detected, so then you can leave a voicemail at that time. Right, so those are the kind of the 2 different modes that you can.
Okay, and you can tell it in one sequence, wait for beep, and
play this message.
Play this message.
That's not supported today.
Okay, so it comes back.
It comes
so
back.
There's a little bit of delay on the message play.
Yeah.
Yes. It's a small delay, but yes, you're right. It does webhook back to the app, and then you respond back with the play.
Pretty minimal, right? Like 15 milliseconds tops if you've got it set up properly.
Gotcha.
There are ways to optimize that so that it can happen as quickly as possible. For example, with a play that you're providing, that audio, how is that stored and provided? So happy to talk through some optimizations about that as well after.
Last part of this, is the beep part of the detection, is that highly accurate versus, I know V1, it was estimated maybe 80% accurate, and you didn't know whether it was false positive, false negative, but is the beep part highly accurate?
The beep part is highly accurate with the latest solution. The accuracy challenge is more around the initial human versus voicemail detection. If it detects that it's a voicemail and it is a voicemail, it's very accurate in the beep detection.
Okay.
The challenge is mostly around human and voicemail, particularly in the example I mentioned, right? Because sometimes the characteristics of a voicemail greeting in humans are similar, right? That's the challenge.
Okay, I lied. I got one more. So is there a webhook or a way to say, hey, I'm a human. I detected it's a voicemail. I want you to wait for the beep and then do a play?
That's fine, right? So you get a webhook, whatever it detects, and then you can kind of control.
No, but it's kind of like take AMD off the table. Just give me wait for beep so I can let the human who's in the conversation
Yeah.
make the determination, do something on my end, and then disconnect that participant, but be waiting for the beep.
Right. So AIM,
Oh, okay.
Yeah.
So it's built.
It's
Okay.
built in, right? Because you would get the beep, and then you control if you want to leave your agent in there to leave the voicemail manually. We can talk after.
Okay. Yeah. Let's talk afterwards.
Any other
Cool.
questions?
Any other questions?
Can you share any like statistics or feedback from customers on what percentage of them are using this background AMD and what percentage of them find that these tuning parameters are sufficient for their purpose?
So background AMD, because there's work for the customer to build this workflow, and it's not a trivial workflow. We only had a couple customers actually implement it. They've been very happy with the experience. So what's one of the other things that, to want to get feedback from you guys is that the type of experience that you would want. So the customers that have built it are happy with it, but it's a very small percentage of customers. Tuning, we've just recently launched, so again, just a few customers have started using it. Again, successful, but there is performance trade-offs. Some customers, they have a particular use case that is more important, or they've seen a lot more calls that fall in that scenario, and so they want to tune towards that scenario with understanding that there's some other downstream effects. So that's the kind of individual decisions that you need to make.
Got it. And just a clarifying question on the situation of the voicemail where it incorrectly detected that I was a human. So the voicemail would start to play and there would be a pause, and then is that the point where the play message would start?
There's the voicemail greeting is short, and then there's the pause. And if it's incorrectly detected, at that point the AMD is going to say, oh, that sounds like a human. Short greeting and a long silence. And so it'll respond back with a human, and then if you play a message as if it's a human, then that's not a great experience there. Does that make sense?
I'm just trying to picture how the background AMD plus the implementation of the AMD,
Right.
Yeah.
how that handles and what it actually sounds like with the voicemail
Gotcha.
that you demoed.
Yeah.
Gotcha.
So in the case where it is a human, right, you would hear that whole intro audio message, and then after that, the agent would introduce themselves. Or if it's a machine, let's say it's answering machine was detected, you would actually kill that audio message right away, and then play a new voicemail as soon as you hear the beep, because Twilio will tell you, hey, the beep's here.
Got it.
Yeah.
But when is the background AMD message started?
As soon as the customer says hello.
Got it.
So you don't want the customer to have any delay, right? So as soon as I say hello, it's like, hey, this is Al Bain contacting you.
Got it. All right. Thank you.
Yeah.
Thank you.
When it's connected, correct.
That's actually, that's a good
Yeah, that's a good
clarification,
point.
right? Because it's not making a detection at that point,
Yeah.
so.
There are rules on outbound dialing. So there is a best practice that you have to play a message before you do something, because there's a problem if you drop the call, and that can be really bad for a customer.
Violation, yeah.
Do you guys have any roadmap when you can avoid all that conference and second leg that make that the background AMD as a product, like having a play message in background AMD? I think that would be useful in any case in outbound.
Yeah. Yeah, no, that makes sense. Don't have specific timelines, but that's something we are definitely looking at. That seems like the right improvement to the product.
Yeah.
I think my question is actually related to what he was just talking about. But so when that message starts playing, right? You said you start playing that message as soon as it's connected. Wouldn't that change the behavior of the person who's picking up the phone, so they might not say hello, and then you wouldn't be able to detect anything? Or that's why
Yeah,
Should
so-
we wait a few seconds before we start playing a message? Or
Yeah, I think there is a little bit of a delay in playing the message still. You don't play it immediately when it's answered. A little bit of a delay to allow for a very short greeting, but you won't get that 2 or 3 second delay, which you will sometimes get with AMD.
So when you're playing an audio message right through Twiml, you can always throw in a pause for 500 milliseconds or a second. So you do that such that I pick up hello, and then it just times it correctly, right? Now, if the greeting was, hey, it's Ankit, it might overlap just a bit. So there's no, yeah.
Yeah.
Awesome. So it looks like we're at time. Thank you, everyone.
Thank you.